everyone. Let's get started with an exciting podcast today with ADYPU podcast series that we are starting on our YouTube channel. So today we are going to talk about India's growing infrastructure in space technology, how space technology is advancing in India, and how we are looking into this industry and approaching it. I have a guest speaker today who's going to be joining us for this fascinating discussion, Dr. Jyoti Singh. She's also a program leader with ADYPU for the space technology program, master's programs. We are going to talk about the ISRO's PSLV Integration Facility, which is at Sriharikota, the Semi-cryogenic integrated engine and state test facilities, which is at Mahendragiri, Tamil Nadu. And also we'll talk about the Trisonic Wind Tunnel at Thiruvananthapuram. For what use these facilities are going to be in our space technology programs, and how India's satellite launch capabilities and propulsion system testing and all these details we're going to talk about with Dr. Jyoti. So, Dr. Jyoti, you can go ahead.
I'm the program leader for the MTech program in space technology at ADYPU. And we have recently started this program. We have completed almost 2 years now. And we teach various aspects of space technology engineering as such. And we also cover what is the specific, special features of the Indian space mission, and
Right.
what ISRO does, and how Indian startup and private industry is coming up in space field. So there is a great need for engineers with knowledge of space technology that our country faces right now. And
Right.
so we are very excited that we have launched this program at the time when space technology is really in the minds of all people who are making India's space policy and so on. They need engineers who understand space technology. So that is the background with which I am involved in the space technology program of India, and of course the course that we teach at ADYPU. Now
Right.
we can talk
Since you
about
told me as well that you're an astrophysicist, you're a scientist
yes, yes.
who
So
research
my
into astro.
training, yes, my training really is in physics, mathematics, and later on I went on to do research in astrophysics, where I used a lot of data that was captured by the satellites. At the time when I was doing my PhD, in fact, India didn't have a satellite of its own for collecting astronomical data. So we used, in fact, me and my other colleagues and other students who were doing their PhDs, we used data from obtained by NASA or ESA, the European Space Agency's data. At that
Understood.
time, already ISRO was developing these, and as we grew older and got more and more experience in this field of Indian space missions, ISRO, of course, became very successful, and finally we now have AstroSat, which is an astronomical space load specialized mission, which was
Right.
launched by India ISRO a few years ago, about 6 years ago, I believe. And of course, in the last 70 years, India has developed its own unique organic space program, which catered to the Indian needs. So it's a very exciting field
Exciting
and
time.
inspiring times. And India has now launched these three great infrastructure projects for space that we will talk about today. I hope to
We'll talk
be
about today. Perfect.
light on that. Yeah.
Absolutely. So we would like to know in general, like how these technologies are, and I'm going to first start with our first question, which is, could you just tell us what is the PSLV Integration Facility, which is also called PIF? It's at Sriharikota, and
Yeah.
it's in Andhra Pradesh, state of
Mm.
Andhra Pradesh in India. So you
Yes.
can definitely shed some light on that.
Yeah, so at Sriharikota in Andhra Pradesh, which is a very convenient place for launching satellites because it is very close to the equator, there is this first launch pad, as it is called FLP. Now, at that FLP only, this new PSLV integration facility is built by, it was inaugurated very recently, I believe February end or March beginning. And it is a
Right.
very significant milestone because, these PSLV rocket or GSLV, you must have heard these names. These rockets are made up of a huge, pieces which are engineering marvels in themselves. Then they have to be
Right.
assembled, integrated, and tested to work as one launch vehicle. And this is a very
Vehicle. Understood.
critical process. And it is done as the last stage of the building up of the launch vehicle. And
The
then
final product, the final
satellite or the
launch vehicle.
payload is kept on the top of this launch vehicle, and then we launch it. So
Awesome.
the PSLV Integration Facility, as it is called PIF, is our new integration facility. So earlier also there was, we obviously did this, but now it is going to happen in one place in streamlined and very systematic manner, and we are going to be therefore be able to assemble, integrate, and test the launch vehicle in a much shorter time. So, for example, early
Okay.
India has been launching about 6 PSLV, rockets in a year. Now that
Okay.
annual launch frequency is going to increase from 6 to 12 or 15. That is going to boost in ISRO's commercial prospects and revenue, along with India's own government-sponsored projects, as well as India's own startup and industry, private industrial growth of space field is also going to be enabled by this new facility, which is going to make the assembly of the final launch vehicle in one place in a very
Right.
systematic and streamlined manner. So that is the PSLV integration facility. And along with the PSLV launch vehicle or the rocket, which is India's most strong rocket with which we are sending our most ambitious payloads. It is also
Right.
capable
Okay.
of assembling smaller rockets, which are used for smaller payloads, and such as
Satellite, maybe.
telecommunication satellites or
Right.
weather monitoring satellites. So there is a lot of demand for sending
Right.
smaller rockets also, and so a quick assembly and testing of smaller rockets will also improve our capacity to launch many more small rockets as well as many more PSLVs. And so there is a very great, sort of a boost to the entire space activity that India can do. So infrastructure development is what finally leads to developing the whole sector. And in that sense, it is an extremely important milestone for India's
Right.
space vehicle.
Of course.
And there is a supporting platform. So this whole
Right.
rocket is built there, and it is
Right.
then rolled out. It is sitting on huge wheels, and it is
Wheels,
rolled
yeah.
out using
To the launch
rails
site in
to the
case.
launch
Right. Okay.
pad. So it
Site.
is built
Okay. Perfect.
near the launch pad so that it can easily be brought
It's
out
easily
once it
transferred.
is integrated, transferred very easily. Yeah.
Awesome. So the development is going to make our work easier, and it will help us give us, it's kind of a more resources which will help us get
Yeah.
into more complex
Maybe,
designs maybe in the future.
it is like, suppose,
Doing it in vast products also, like making more. We are doing 6 right now,
yeah,
so we'll
we
be
are
able to
going
do
to produce many more such
15.
launch vehicles, and therefore
Right.
obviously be able to launch many more. And then, the other countries also, which do not have such capability or may
Right.
have limited capacity, come
Can
to us saying,
help them
here's
out. Right.
our payload, here's our satellite, will you launch it for
Right.
us? So now
Right.
if we have the possibility of making many more rockets in much quicker time because of this new facility that is built at Sriharikota, then we can take up more contracts from other private
Of
industries
course,
abroad or
because
other
you're
governments.
Right, because I do get this is in terms of business, but I do, since we are a university, we do get science students, space tech students who are abroad, and they are very much interested in learning how ISRO does its job, or maybe how Indian approach space
Yes.
technology education. My next question, which is the next state of the art facility, semi-cryogenic integrated engine and state test facility, which is in Mahendragiri. I guess Mahendragiri is in Tamil Nadu,
Hmm.
as you said. So,
Yeah, yeah,
yeah,
yeah.
you can tell us what is cryogenic engines are, please.
Yeah, yeah. So, we are using in PSLV one kind of propellant, for the rocket to go up in the skies, in the space. You use this ignition fuel, and then there is a propellant which is burnt, and with that it develops a thrust, so to speak, a push, and that's how the whole launch vehicle goes,
Right,
is sent up in the space. So obviously, ISRO would like to advance its capacity to, launch bigger and better payloads into the space. And so far we have been using PSLV with a solid propellant type of technology, and now we are also working in liquid propellant technology. In ISRO has centers where they have this liquid propulsion system center and uh, propulsion complex, ISRO propulsion complex, both are in Mahendragiri. And now this new facility, which is called Semi-cryogenics Integrated Engineering and Test Facility, it will give us a sort of a teeth, in the sense that we can now do this testing of these new propellant mixtures and new technology ourselves, and therefore develop much better engines to send these rockets up in the space. So basically, cryogenic engines means engines which use liquid propellant. So a mixture of liquid hydrogen and liquid oxygen is used
right.
as fuel. That is cryogenic. Now,
Okay,
semi-cryogenic uses, in fact, a mixture of higher grade kerosene that is developed by ISRO itself, actually, and
okay,
liquid oxygen. So it's a mixture of, when the ignition happens, it is a mixture of liquid and gaseous phase of the propellant.
okay.
That's why it's called semi-cryogenic. Now, by developing this facility and therefore successfully carrying out tests, we are going to increase our capacity. For example, ISRO wants to develop a 2000 kilonewton thrust semi-cryogenic engine. So it is much more, um, the capacity to
Is
take much bigger payloads, because the
right,
thrust that is developed is 2000 kilonewtons. So this is, you know, sort
which
of,
is a lot.
yeah, 2000 into 1000. Kilo means another thousand. So it is
Right.
2 million Newton thrust that is going to be developed if we, when we succeed, not if, but when.
When?
So
Okay,
first test of using this facility was already carried out on May 2nd May. A pre-burner ignition test, which is crucial for engine operation, that was carried out at this facility that is developed already. So already it is demonstrated that this facility is working very efficiently, and it is going to lead to much better engines, which will allow us to improve our capacity to send bigger and better satellites into the space, and also have man missioned, crew,
Gaganyaan
Gaganyaan,
missions.
whatever. So we basically, this is the first facility that we discussed, the PSLV integration facility, is consolidating the technology that we already know by making more efficient and faster production line. So we are going to make many more such rockets, integrate them, test them, and have many more launches. This second facility, in fact, helps us in developing better and more advanced techniques of having stronger rockets, launch vehicles, and by using some different propellant mixtures, and so on and so forth. So this is the
Right.
R&D part of the
Research
whole
part of
program.
it.
So we have to
And
do development, that
test
is,
it and then finalize
both
if in case.
are important for the development of a space program for any country. One is to innovate, do research and
Innovate,
develop,
right?
take up challenge, engineering challenges and work out solutions of that.
Right.
Uh, and the other is to already establish technology through research and development to then do the actual production of that and make it more and more efficient and more reliable and 100% failure proof kind of technology. Obviously there's nothing 100%
Absolutely.
in anything man-made, but as reliable as is
You
possible.
need a place to test it, at least when you
Yes,
will
and that
understand,
testing facility is
will help you with the
correct.
data, and will data will help you build a better this product that you are
Yeah, so you establish a system,
system, yeah,
and then you have a
innovation system, right?
production line. So everything is crystal clear. Then once we do the
Right.
innovation and test it, and many times we test it till it becomes a reliable technology, and then we send it for production. So that's both these facilities actually signify development in both the areas that are very
Understood.
important for us. Now, these
Right.
wind tunnels are actually used as a facility. It is a long tunnel of say 160 meters. This particular new facility that they have come up with, and it has the ability to simulate flight conditions from subsonic to supersonic speeds. So the tunnel offers a testing place
Okay.
where they can actually do scaled models of rockets. They can send through
Understood.
this tunnel and
Okay.
monitor various parameters, such as to test
Design,
the aerodynamic
aerodynamic
of
design of
it.
it.
So, what is the
Right.
resistance that the spacecraft will have to face? So, all those
Mhm.
conditions that the spacecraft is going to go through at the time of launch. So while going through the atmosphere to the outer space, as well as when the eventually India wants to build up a capacity to bring back our spacecrafts also, the capacity that NASA has, for example. So when we want to do that, at the time of re-entry also, these spacecrafts are going to face a lot of resistance due to the Earth's atmosphere and so on. So the aerodynamic design of rockets to face this atmospheric turbulence and all that, that
Mm-hmm.
testing facility, so that we
Understood.
can understand how to design these spacecraft so that they can withstand the type of drastic conditions that they have to go through. So that
Right.
is the main purpose of this Trisonic wind tunnel that ISRO has built in Tiruvananthapuram. So there
Right.
are various tests that scientists do.
Various
First of
tests. I
all,
think
they
there are
do
simulations.
simulation.
There are simulations also, ma'am. If I'm not wrong, there are some kind of computer simulations also, which are helpful for
Yeah, yeah.
testing. I think
So
the
what
same
they
thing.
can do is the computer simulations are, of course, obviously based on the algorithms, and
Math.
it is theoretical.
Okay.
So now they can
Right.
send actual models which can actually be made to go through this wind tunnel. They can increase the speed of the wind, and they can make it stronger thrust and so on and so forth, so that they can test the stability of the spacecraft, its structural integrity, that is, it should not kind of develop any cracks or break down.
Understood.
What is the noise and vibration that that spacecraft is going to be able to withstand? What is and so basically it is going to be doing the validation of your computational model. People have developed computational model. Now this test facility where they will actually carry out those tests, it will validate whether our
Okay.
computational models were correct or not, and then
Good
we
or
can
not.
go ahead and design the spacecraft. The aerodynamic design of it
Basis
can be done on the basis of
okay.
these tests that we will
Details
carry
which
out
data
in
which we
this
get,
wind
right?
tunnel. That is
Understood.
the
Okay. So what would you like to
yeah.
tell these engineering students about, if in case they want to get into it, what kind of a mindset, first of all, they should have? what kind of preparations they need to do. For example, what kind of subjects they need to study good so that they can be a part of a space technology program and all that. So I would like to know from you that.
Yeah. So, first of all, you should have a natural curiosity and passion for
Curiosity, right?
understanding how exactly this space exploration program was developed
Works.
in India and how it is going to be carried forward. I mean, we have, okay, we sent the our mission to moon. So is that the end of
Right.
it, or that's not where India wants to stop?
Of course. Right.
And so what are we going to do in future, which is so exciting for people like us who have spent a whole lifetime seeing how India slowly and steadily made progress and achieved its goals, and therefore, you know, acquired a name as a very trustworthy space program in the global scenario. So
Global.
first thing
Right.
is to build a strong foundation. If you want to go into any engineering aspect, in fact, for that matter, but more so in space program, because this is a very harsh kind of a field. You know, no mistake is allowed, because when you
Of
send
course. Yes.
something out there in the space, if there is any mistake, then that's that you don't have opportunity to correct it.
Of
You see,
course. Yes.
once it's gone, you have to just wait and watch and hope for the best, that what you have put it into that satellite is all correctly done and it's going to work. So you have to be you have to have your foundations built very well. So obviously you have solid educational background in STEM, which is science, technology, engineering and mathematics. Up to 12th standard, people should be very strong in their study of mathematics and physics. That is the basis on which your entire engineering knowledge is built. And
Right.
then when you pursued your undergraduate and graduate, postgraduate education, you can take up any branch of engineering which is required in space technology. See, space technology is one area where so many different branches of engineering skills come together. So you need mechanical
Right.
engineers, you need electrical engineers, electronics, aerospace, computer science. You
Software
name a branch of engineering and
design, a
it
lot
will
of
be
things.
required in space technology. While you are doing your graduation, what you should do is gain practical experience. So you should try and do
Right.
internships, take up some research projects, do extracurricular activities like,
Activities.
there are so many competitions held, hackathons are there, workshops are
Right.
conducted by ISRO. They call students to participate in 1 week workshop, or one or 2 months online training sessions are there. So these are things
Right.
which you can acquire while you are doing your engineering, and you can build your practical skills as well as expose yourself to the real world challenges through all this.
Right.
You should try and do at least keep an eye on opportunities which are announced by ISRO. ISRO has been actually one single place where entire space science activity was going on. But now that is
Correct.
changing very
Right now.
fast, because Indian
Right.
space policy is changed and a lot of private players have come in. There are a lot of startups, there are a lot of private industries which are trying to take part in the space activity. So in terms of getting internships, for example, you might be in an electrical engineering course or a computer science course, but you can associate with an industry, with a startup which is into
Which
space
is in space
technology, which
technology.
requires you to, do your
Right.
develop programs and algorithms which have application
For
in
this
space
industry.
technology, but
Right.
which is part of your
Right.
computer science internship, for example, and so on
Understood.
and so forth. So this way you can stay informed, and as you work with these people, you will get inspired to get into the field and carry on more research and development and build better and better space missions.
Right.
And believe me, there is no great joy than being able to do something which is something innovative, and to
Right.
which the whole your not only academic community and the engineers of this country and
Everyone,
the
right,
whole world looks up to you for
looks up to you.
developing
Yes.
something new, which is useful for your country, your people, and it is also useful for gaining, globally, knowledge development. So if
Of
you
course.
are persistent with your studies through your undergraduate and postgraduate, MTech program and all that, especially in India, actually, there aren't that many MTech programs which specialize in space technology. If I'm not mistaken, in fact, only this year, many
Right.
space technology specialization engineering programs are being launched. We were a
Launched.
little
Yeah.
earlier than others.
Right.
Our first batch is going to pass out
Right.
this
Right. Of course.
July. And so now is the time to develop your interest in space technology. You have your education available. MTech in space technology is there in many
Right.
colleges, including our college. It will be there in the next few years. Some colleges, some IITs and other engineering colleges, in fact, are incorporating one small part of it as a minor in your undergraduate program itself, in BTech itself. So there is
Right.
a lot of
Okay.
opportunity to study this and enter the interesting field. And the reason why for India it is very important is because we developed our program organically by looking at what
Right.
India needs. And when this long back, Vikram Sarabhai
Right.
and these scientists developed this program, they were looking at what India needs
What
most.
we need.
And
Right.
at that time, it was we had a lot of problems in agriculture sector, medical sector, education,
Right.
telecommunication, prediction, what will be monsoon like, if any disaster is happening, how to communicate quickly so that
Right.
we can send rescue teams. All these sectors are developed by the Indian Space Mission. We have sent so many telecommunication satellites, INSAT and all. Even this
Right.
discussion that we are having online is because we have our own Indian satellites in the sky,
Satellites, of course.
which are,
And it is also for us affordable because other parts of the world it's very expensive to have internet. We in India we really are blessed to have very
yes, that is
economically
true.
budget internet services. Anyone, especially students, they don't have much budget, so anyone can use internet. So that's the best part about
Mhm. And this has happened
satellite.
because we have systematically developed our
We have
space
like yeah,
program over the last 60, 70 years. And
right,
so entering it at any point of time was interesting, but it is even more interesting now because now the boost for
right,
development across private sector and all is better than any previous time when it was all
absolutely,
because India needed to fund its space program, so ISRO was doing all that. But now we have opened the doors for private partners to come into
absolutely, absolutely.
developing.
And that
So
was exactly my next question of discussion was that India, since we have Adya Aerospace and Planet Aerospace, we do have collaborations where our students last 2 years have been
yes,
going there
yes,
to practice. Since you have
yeah,
already said that, and we have an online also we connect with students through online. They are always connected. For example, they are not only in college, when they are home they are connected with workshops, worksheets,
yes, yes,
webinars and
yes.
such,
And
which
in
are
fact,
ongoing.
we send them for actual hands-on experience to various
Absolutely.
industries.
Right.
And while they are actually physically located where the industry is, we are
Right.
connected with them, and we also conduct some lectures online so that we are able to teach them while they are also doing their internship and so on. So it's a very flexible
Absolutely.
program that we have
Flexible
here.
program.
Mm.
Yeah, because they go to Bangalore. I know that I was there. The first year programs they had
First
gone
year
to
they went to
Bangalore.
Bangalore.
So
Now
it's
students have gone
Adya
to
students,
various
yeah,
parts. Yes.
various
Now
places.
they have
Even
in fact
today,
gone
there
to
are now
many other
startups.
industries
Yes,
also.
yes, yes. Yeah, yeah, yeah.
Mm.
I think the very initial space technology startups were started off in Bangalore, and now they are everywhere. Now they're opening up
They
in
are
Gujarat
spreading.
also. They're opening up in UP kind of
Hyderabad
places. I've
has
heard that there
many.
are some. Absolutely, yeah.
Yeah. Bangalore,
Right.
Hyderabad, Thiruvananthapuram, so it was mostly in southern parts, but now it is coming to
It is.
Maharashtra,
It is
Pune,
because
Bombay, and then also Gujarat and so
Right.
on. So it's only growing. In India, the space sector is only
Absolutely.
growing, and this is the right time to jump into it, I would say.
Right. And we also have renewable energy programs as well. And
Hmm.
since you have said that in Gujarat and Rajasthan, these projects are mostly focusing on renewable energy, and
Yes.
somehow it is related to science technology as well. We wanted it, that's our initiative to even bring more videos like this. So if you guys have watched it till the end, and if you have survived this video so far, please hit the like button, subscribe to our channel so that you will get a notification of our next podcast. So please go ahead and subscribe to this channel. I really enjoyed talking to you, Dr. Jyoti, and let's meet maybe in the next conversation with a new topic.
Sure.
I'll get a new topic for you to
Okay.
discuss on it.
I look forward to that. Thank you very much.